Hi, my name is Gerli. I'm a consultant for Wolfram Research, and I'm giving a talk on the computer-based math and how it works in the cloud. Okay, hello, good morning. My name is Gerli. I'm going to be talking to you about computer-based maths. This is an initiative that is originated from the UK, hence the plural at the end of the maths there. And I'm going to be talking about CBM, computer-based math CBM, and how it currently works and how we got it to work in the cloud. So just to start off with a short little background into what is CBM in the first place. So CBM is a kind of initiative to redo maths education. So kind of current maths is very sort of calculating based. It's very, let's hand calculate, let's, figure out all the technical details. And the CBM initiative is really more about, let's do more of the thinking. Let's have students do more of the problem solving. Let's do the translation from a problem to something that a computer can understand, and then the translation from what the computer gives you back into human language. And so the things that I'm going to be showing you are the materials that we have built to help, help do this in the classroom. So we have these modules and that we've created where we start out with a question. So for example, how happy are people in my country? And then we try and answer that question. So we don't start with, this is how you calculate square roots, this is how you solve these equations. We start with a question, and then we introduce the tools that are necessary to solve it. But I'm not going to go a lot more into the details about what is the kind of idea of this. I'm going to be talking more about the technical details of how we build these modules, how they work on desktop, how they work on the cloud. Okay, so as I said, we have built these modules. We have built these kind of structured documents that guide the student through answering a question. So there is a way for you to try this out. I will have these links on the summary slide as well, and they're all available for you to, after the conference, you can get the notebook, you can get all these links, so you don't have to hurriedly scribble them down. You can try this out on desktop for yourself as well. We have a link on the CBM website for downloading a module. So this is for desktop use. So this is our current delivery mechanism. So we've had prototypes out for, I think, quite a few years now, and the delivery mechanism has been desktop based. So this one specifically is if you have Mathematica installed already, but we do have versions that work with Wolfram Player on desktop as well. And the way the desktop client has been structured is that we've built this as a Packlet or as an application that it contains notebooks. So notebooks, CDFs, I guess nowadays they're basically the same. We also have a custom style sheet. Here's a little screenshot of how it looks like. I will open it up as well. There are various package files that we include as well. So it is quite a big there's quite a lot of infrastructure that we've built to make these materials, be nice and interactive and have, look beautiful, all sorts of other things. We also include image and data resources. So we didn't want to include quite everything in the file itself. The notebook files would get big, and some things, we kind of want to allow different data resources to come in. So we do include quite a lot of files in the layout. So the reason I talk about this, how we built it up on desktop, is that all of this we have now had to make work in the cloud as well. And I will get to what the cloud, how we've kind of made all of these files work together in the cloud in just a bit. But first, let me actually open up what the CBM materials look like on desktop. So we deliver this with an installer. So the installer creates a desktop shortcut as well, which will fire up this welcome screen. So this is a Mathematica palette. So as you noticed, I opened it up from the palettes menu, and this is kind of like a single entry on desktop. Like, we assume that everyone will come in through this welcome screen. They can log in. So we've built this kind of collaboration framework. We have a server as well. I'll talk about that in a little bit. And then they can open up a module. So the one I'm going to show here is this. This is the one that we're prototyping on the cloud as well. And it's this it's a slideshow notebook, right? So it has quite a lot of, so we have some summary slides. So this one specifically here is a teacher version. It has a lot of these kind of orange boxes here for, so I don't want to get into a whole lot of detail about, the kind of structure of these. I kind of just want to focus on the technical details, really. So I'm going to skip over a lot of what these things are. So let me just open up a student version. Yes, a student version. And the way that when a student opens up this module, what they will see is, they will have some introductory text about what's going on. They have some, where is this? Scroll down, please. And of course, it's not opening. Okay, so they have this notebook that has a lot of text about what's going on. They have these interactive questions, so you'll see there's a send button here. So you can connect to a server, you can answer questions, you can send this to the server. The teacher can pull all these answers in, show them on their screen. There are these, let me just get example data here. So there are quite a lot of these, let me try and click on this button. A lot of dynamic interactive elements that we've built as well to help students explore different data, different sort of methods of things that they can use. These are all things that we've got working in the cloud as well. But just to kind of give you an overview of what's going on. So here is an example question where you can kind of drag things into the right place, and then it will go ahead and check your answers for you. So again, this is something that can be used in a teacher-led environment. This is something that can be used in a student just goes and kind of studies this on their own. We have self-checking answers, self-checking questions, et cetera, et cetera. Let me just find a link somewhere here as well. So this is just one notebook here currently. This is a module notebook. We also have these things called primers that will help you, just go into a bit more detail about some specific tools. So for example, what is a statistic? What sort of things are interested in, what sort of things are relevant for it, what to watch out for, what is it, what are linked tools, some sort of things to help you learn this tool, this concept a bit better. But again, here, like on desktop, these are separate notebook files. And we've all, when we've delivered this package of CBM materials, we've just bundled all of this together and the installer puts them in the right place. And we have some then, tools that you can use find file or something like that knows where to find these files relative to where you have installed them. Now, so that is the desktop version of the materials that we have. Now, how do I get back to this? So I believe I mentioned that yes, we have all these notebooks. We have a style sheet, so you notice that this is a standard Mathematica notebook. It's just that we have quite heavily added styles on top of it to give it a different look, or as well as to kind of all these styles are intended to kind of help emphasize the right things and make it look visually pleasing as well. So it does look pretty. I'm very happy with that. So that's the client side. We also have a server. So I briefly mentioned that we have these questions. Users can log in. They can answer questions which get sent to a server. That then the teacher can pull in answers from that server and show these, do analysis on that, show these to the class, etc. That server we have built with uses a kind of large stack of materials. We have technologies. We do use Mathematica and Web Mathematica for this currently, and we're using a JSP fast and URL execute from within the client to then call back to the server. So the server, I'm not going to go into a lot of detail today because for the cloud version, we didn't need to do anything with the server. So the server is, that's living somewhere separate. The cloud client can call the server just as well as it can from desktop. So, but just to kind of note that this is also, we have this client that calls out to something on the outside as well. So it's not just kind of localized. Now, on to the cloud version. So there is a link here where you can actually go and open it and try it out yourself. So this is deployed currently under my own account. This is distributed as a developer preview. So this is not an official release of any way. We are currently still kind of still figuring out a few little kind of how do we distribute this, a few little kind of bugs that are related to just kind of moving to a different delivery platform. So it was Wolfram/CBM Cloud Preview if you want to try it out. But again, I'll have links on the final summary page. And this looks essentially the same as the version that we had on desktop. So one difference here is that this thing includes these little videos. So this version is intended for self-study as well. So we've had Alec here, who is the CBM content manager. He has recorded these videos to help you kind of make better sense of what's going on, help you if there have been any answers, any questions that you've had to answer, explain why some answers were like that, etc. So there are these little things kind of included in here as well. So let's start the module. Let's go to a few pages ahead. And you can see that this is a slideshow notebook, and you can see that it really kind of it works quite well. So let me do a get example data here. Let me just choose a random boy and girl. So just dynamic interactive content that they can explore. Just works on the cloud. It's beautiful. So here we had this. So some content does take a little bit longer to load. So one of the challenges that we faced with getting this content from desktop to the cloud is that we're very dynamic heavy. So we have a lot of interactive content. And on desktop, all of this, we built first on desktop, and then we moved to the cloud, which is, not the ideal way of doing things. So we were kind of, just used to things like, communication between a front end and a kernel being instantaneous, which may not be true on cloud, for example. There is a kind of longer round trip that is required. So, because because we had the desktop at first, that's kind of what we've been doing. But, overall, it does work, pretty much the same. Here's the, Great, I don't know what happened, as usual in a demo. So here's another one that is a, kind of drag and drop that you can just drag around. And it has, does it show that some of these are green, some of these are red? So which have been dragged to the correct place, which haven't been dragged to the correct place. Try again, and it's just, I think there's like the tiniest bit more sort of lag between, when you click a button and something happens, but it's all, I think, all within perfectly reasonable response times. And so that's the version on the cloud. Another thing, so I opened up this primer this primer file on desktop as well. So let me open it up on cloud. And again, you can see we just have these kind of links between notebooks that kind of all just work. And this can link back to other primers, et cetera, et cetera. Now, to talk briefly about kind of some general differences that we found when we were doing this transition from desktop to cloud. So in the desktop version, we have a very specific entry method into the tool. So we say, either you go have a shortcut that takes you to the palette, or you go into Mathematica palettes, open the CBM palette, and that's the first thing you see. And so that palette then has all sorts of things that it does. It loads in package files, so it does all sorts of initialization because we know that this is where the student will come in or the teacher will come in. We know stuff will be handled there, initialization will be handled there. Any other file they open, it can rely on code files being loaded. With the cloud, that's not the case. A student can go ahead and bookmark any of these pages individually. They can come in from wherever. We can't really, there is no single entry route because we have all these different pages that they can view and they can come into. So we are still kind of figuring out some initialization issues related to that. We haven't quite this is also one of the reasons why there's no official release of this yet is that currently, if you don't, you have to open the module file first for everything to work correctly. So, just so you're aware, it doesn't work. It doesn't all work, but we know what we have to do in order to get get there yet. Another issue is that you can assume nothing. You have no idea what the user has on their machine. With this desktop version, we know that they came in, they installed these CBM materials, which placed certain packlets in certain places, certain files in certain places, and we know they're there. We know where they are. Well, we know roughly where they are. And then when we open the CBM materials, we can just go, please load in the CBM packlet, and everything will just work. Here, we can assume nothing. The user can go to this web page. They have nothing on their account. So we do have, so you might have noticed here that I have opened this. This is the product view. This is not a deployed view. So we do want the students to be able to kind of edit these files so they can go and go in here, create copies of these notebooks for themselves, add code, edit code. So we wanted them to be, have an experience like in Mathematica. But it's not quite the same as in Mathematica because they come in with a clean Mathematica, sort of like a clean Mathematica installation. And so that's kind of something that we had to then work out, is how to pull in the necessary code live when they open the notebook without knowing where they're coming from, where this file lives, etc. Another thing is that we don't know where this file lives. So we said we want the user to go in and create a copy of their own. But that means we can't assume that next to that notebook there will be some other file that we can then conveniently load in. So we can't really use relative paths to find other files. Another thing that the user can do is they can download this notebook, and suddenly we're not living on the cloud at all. But we still want everything to continue working, and it does. If you download that notebook, everything will still continue working. So, a few specifics. When loading in the packlet, when loading in the code that is necessary for that module to run, on the desktop we can just go load in the main CBM packlet and load in the module-specific packlet code. And then Mathematica knows, okay, so since we've placed these files in the correct location in this user-based applications or base directory applications, everything will be just found. On the cloud, we cannot do this. So on the cloud, what we've done is actually we've hard-coded into the module, go directly to this URL, and this is where you will find the packlet. And the reason, this sort of system does work if you just if you install a packlet under your own cloud account, and then you're that user that goes in and loads in the code. But if another user who has not deployed this notebook, who doesn't have these packlets installed in their account, this thing doesn't really mean anything. The cloud Mathematica does not know where to go to find these files. So what we've done is just said that this is where the CBM packlet lives. So we have gone and directly gone into the load the init.m file to get the packlet. So there is I can show you what that. I thought I could show you what that init.m file looks like, but I think my Mathematica just died, so that's fun. Is this the right version? Sorry about that. Let me not show you how that looks like. But anyway, that init.m file, usually your init.m file will contain similar sorts of statements. It will be get package, backtick sub package, etc. But we do just say a bunch of different load a file from this location, load a file from this location, load a file from this location. And note that we're not using cloud objects here. The reason that we've done that is because if you download this cloud file and you want to open it locally, if you do a get of a cloud object, there's some interference with what your current $cloud base is set to. So if you're someone who works with private clouds or some other sort of test environments where you might not just use the public cloud, this kind of ensures that there's a specific URL that it goes to. It doesn't kind of that file has been set to be publicly available, it's executable, you can load it. There's no need to kind of interfere with the cloud object system. So yeah, another thing to note is that if you set your, if you just set a permissions to public, that's not going to give it execute privileges. So I think you can't, correct me if I'm wrong, but I think then you can't easily just run the code. So you have to explicitly give it execute privileges as well for it to work. This was set up a while ago, so maybe some things have changed, but this is what we kind of needed to do to make sure that you can actually then, run the code, load in the code so it executes. Another thing I mentioned is that we're not using deployed view, we're using product view. So one thing that you might have noticed here is that, so in the current iteration of the cloud, I think this has been true for several versions now, there's this either /obj or /env. So all the notebooks, for example, these open in product view, so we have this env here. So if you change that env to obj, then that will give you a deployed view. But we want it to open in product view. At least all the notebooks we want to open like they open in Mathematica, but online rather than on desktop. Whereas all these code files, these do come in sort of like in deployed view. This is so if I copy this and go and put it, this will download the file. So this is like that is the actual location of the file. It doesn't have any, whereas if I change it to this env, it will open like you've opened a package file on desktop Mathematica as well. So it will open, you can see the code and stuff like that. Another thing that, so because I'm the owner of that file, so I just kind of, when I clicked that link, it just opened like it would. If you were to go to that link and open it up, you would get a little bar at the top saying you're viewing, would you like to create a local copy of this notebook? And so we have this auto copy property set as well. And the idea is that once we have it properly set up, the CBM account, which deploys this, that will just automatically create this copy for you. So kind of like Explorations notebooks currently, if they have been deployed by some local internal account, but if you go and open a new exploration, it will just automatically create a new notebook for you. And that's kind of the similar sort of thing we want to do here as well. And then a few other changes that we made to make sure that everything loads when on desktop or when on cloud, when you download it, is to say that we embedded the style sheet. On desktop, we have a link to a file that has all the styles. Here, if you download the file and go file, edit style sheet, you can see all the fancy styles that we put in. Another thing that we do is, yes, we use direct URLs for all sorts of things. So URLs quite like this. So we don't rely on this being on any specific, we don't just say, I think because the file lives at CBM/content something something, so we can't really say, just open something, ... Some other files, we put in these full paths for this is where this code file lives, this is where this image file lives, so any sort of data resources that come in. And all sorts of linked notebooks as well. So these links here that will kind of open up, well, this one doesn't have any linked primers, but this one here, these have, explicit, this is the link that will open. And this is, we have built processes that kind of automatically transform our deploy to desktop content to cloud content, and that kind of turns that relative linking that we do on desktop into an absolute linking that we do on cloud. But, if you don't have such a system, then kind of, you have to make sure of that yourself. And then, yes, noting here as well that all of this ensures that when you download the notebook, everything still works as intended. And this has actually given us a new way of distributing desktop content as well, because suddenly we don't need to distribute this entire Packlet system. We can just have everything, all the code and everything that we needed just be downloaded from the cloud live. It does have a sort of a small penalty in the initial startup time, in that because it has to then download the files before it can load them. So it is still preferable to just have everything pre-installed, things open up a bit faster. But desperate times, then it can work as well. And then just a list of a few things that you might be interested in knowing that just work. We didn't need to do anything that, they kind of they work in the cloud. So we could do slideshows. We did consider going for this MOOC format, this like that Wolfram U uses, so we would split all the slides into separate pages and kind of do that. But we kind of just ended up going with this slideshow notebook, and it works pretty well. Front-end tokens, docked cell at the top. So here, this one here, if it loads, this is a docked cell, so you can see it kind of sticks at the top there. Works perfectly fine. I didn't open any dialogues, but for example, if I just look at this, we have this login dialog that opens quite nicely on cloud as well. So that's a summary of how CBM works on the cloud. Here are examples for it if you want to go ahead and try them out, and feel free to reach out if you have any comments or questions. Thank you.